So example 7, and what is the page number? In page number 8. So what is the question?
A function f x to y is said to be 1-to-1 and onto.
Okay, the function f from x to y is said to be
1-to-1 and onto bijective.
no. You're telling the definition 7. I'm talking about example 7. Below that.
Okay,
Let
sir.
A be let A be
A
something.
be the set of all 50 students of class 10 in a school.
Okay.
Let
It's a set of all 50 students, sir. Is it the name, roll number, anything they mention? The set. Okay, let's assume they are the names. Okay, x1, x2, so on till x50.
Let function A is natural number.
So function from the natural number set to A to natural number set. So there is a function that is mapped from this set A to natural number set. Okay, what is that? What is that function supposed to satisfy? So what is that relation speaking about? Roll number something they will know. What?
Roll number of the student.
So that function should be the 1 minute. No? Let f be a function defined from A to n. N is a natural number set, which is defined by f of x is equal to roll number of the student. So in this case, what are they asking? Show that f is 1-to-1 but not onto. Let's concentrate only on 1-to-1. Onto, forget it. So tell me, what is one? Is it a 1-to-1 function or not? It's very simple. So it's a 1-1 function because you have x1, x2, so on till xn. Sorry, x50. You have 50 students in set A, and what do you have on the other side? You have the natural number set 1, 2, 3, so on till you have 50. Beyond that also you will have numbers, because they didn't say first 50 natural numbers, right? So if x1 is having the roll number 1, the same x1 cannot have another roll number. So to put it simple, each person in the roll, each person in the list is going to have a unique roll number associated. So for every unique input, there is a unique output. Hence, it's a 1-1 function, as simple as that. So what you need to write is, for every student, right? For every student, there is going to be unique roll number associated. So for every unique input value, there is a unique output value. Hence, it's a 1-1 function. I hope it is clear, no? So here we didn't apply that those 4 steps. Shall we try next one?
Yes, sir.
So this one, 8 ones. So look at the 8th problem. So what is the 8th problem telling us? It says there is a function mapped from natural number set to the natural number set. And what does f of x speak about? F of x is 2x. So what are we supposed to prove? So show that it's a 1-1 function but not onto. Right? How to do this? Very simple. So by now you would have understood graphically. If you see, it will be a line passing through the origin. It's 1-1, right? But we have to show it in the exam. No? How do we do that? Consider x1 comma x2 belongs to n. What is the second step that we are supposed to assume? F of x1 is equal to f of x2. So 2x1 is equal to 2x2. You framed an equation, no, solve for it. So x1 is equal to x2. Hence, it's a 1-1 function. Simple. But only thing that you need to be careful about is the domain and the codomain. Because if you see the next problem, what are they speaking? So f is a function mapped from R to R, but here also what is defined? F of x is 2x only. So what mistake I told you will do? We'll take this into consideration, but we need to look at the domain and the codomain. Meaning, if you draw the graph for it, if at all you draw the graph for it and say this is going to be the graph, it is wrong. Why? Because it's only natural number. Means the input only for natural numbers, you'll have the points associated. Meaning, how will the graph look like? 1, 2, 2, 4, 3, it keeps on going like this. Why is it so? Because when you give 1 as the input, output comes out to be 2. Like this, it keeps on going. Basically, this graph is only points. Whereas this graph is a continuous line. You're able to understand? Same function, but the domain and the codomain is changing the whole game. Right? So you will have something like this. Right? So obviously you know the steps. X1 comma X2 belongs to, this time instead of n, it is going to be R. So f of X1 is equal to f of X2. So 2X1 is equal to 2X2. Cancel 2 and 2. X1 will be equal to, and we are done. It's simple. Right? So you'll get something like this one. Right? You cannot do. You can see if you draw a line. Sorry, you can do it. When you draw a line, it is going to cut the curve only at one point. It's not a curve at all in the first place. It is basically a set of points. Like, but I gave you another way of understanding it. What is it I told you? The second element in every ordered pair is different. So that's how 2, 4, 6. It will never get repeated. I hope it is clear. Right. Shall we see what is an onto function? Because we saw 3 questions where they asked us about onto also. Let's try to understand what that onto is. So before that, I want a confirmation. Is everyone having clarity about codomain? Codomain and range, no one has confusion? No? Okay. Shall I proceed?